To find the equation of a normal to a curve at a given point, we need to find dy by dx at that point, so you can then find the gradient of the normal. Normal is perpendicular to the tangent, so the gradient of the normal will be the negative reciprocal, that means 1 over, dy by dx of the curve at the point that we're given, and this point, in this case, x equals 0. So first of all, we need to find dy by dx. So here, that's our function. It looks like we have a product, so we're going to need to look at u and v. So if that's our u and that's our v, then we would multiply, we'd use the product rule. So y dash is u dash v plus u v dash. So if we write u as x squared minus 1, then u dash is simply 2x. And if we say v is e to the 3x, then v dash is simply 3e to the 3x. Again, remember, use the chain rule. You multiply by the derivative of 3x. So now we can write dy by dx as u dash v, so it's this times that, plus u v dash, so this times that. Don't forget the brackets when you have a term with a addition or subtraction. So these brackets are really important. So now we know dy by dx. We need to find dy by dx at the point where x equals 0. That's the point where we want normal. So dy by dx at the point where x equals 0, we simply substitute 0 every time we see an x. So it's 2 times 0 times e to the power 0 plus 0 squared minus 1 times 3e to the power 0. So anything multiplied by 0 is 0, so that's 0. That's negative 1. And e to the power 0 is equal to 1. So it looks like we're going to get negative 3. You can put that in your calculator. So that is the gradient, that is dy by dx. We still need to find the gradient of the normal. So the gradient of the normal is the negative reciprocal of what we just found. So it's minus 1 over negative 3. So it's 1 over 3. That's the gradient of the normal. Now, to find the equation of the normal, it's simply the equation of a straight line. And the equation of a straight line is y minus y1 equals m times x minus x1. And what we just found was m. x1 is given in the question as 0, but y1 isn't given. So we still need to find y1. Now, if you go back to the question, we know y is a function of x, and we know that the point we're interested in is x equals 0. So if we substitute 0 into the expression for y, we should be able to find y1. So I'm going to do that right here. So y1 is 0 squared minus 1 times e to the power 0. So that's simply minus 1, because e to the power 0 is 1, and that's negative 1. So now we know y1, we know m, we know x1, we can write the expression as, or the equation for the line as y minus minus 1 equals 1 over 3 x minus 0. Now, whenever you have a fraction with a denominator in your equation for a line, it's convenient to get rid of that by multiplying both sides of the equation by that denominator. So if you multiply 3, you essentially get rid of that, and then you need to multiply the left-hand side. So you end up with 3y minus minus is plus, plus 1 multiplied by 3 gives you 3. This 3 cancels with this 3, equals, we don't need to write the 1, and we don't need the brackets, and we don't need the 0. So it's simply equal to x. And you can bring it all to the left-hand side. So it would be negative x plus 3y plus 3 equals 0. And that would be your final answer. So that's the equation of the normal. Now, remember, sometimes the questions specify. It says, write it in the form ax plus by plus c equals 0, where a, b, and c are integers. So to do that, you need to get rid of this denominator. So if we hadn't done that, you would have ended up with 1 over 3 here, 1 here, and 1 here. And you would still need to multiply by 3. So the best time to multiply by 3 is here. So here we have the final answer for the equation for the normal.